Good morning and welcome to Technical Safety BC's webinar on electric vehicle energy management systems. My name is Robert Preston and I am an education business partner in client education. I'll be giving the presentation and one of our senior safety officers, Brad Sullivan, at the conclusion of the presentation will be taking any questions that you may have. Today we're going to look at a couple learning objectives, and the first one is we're going to describe and apply the requirements of Information Bulletin IBEL 2018-01. The second thing we're going to do is we're going to describe and apply the processes related to the electric vehicle supply equipment and the electric vehicle energy management system in the variance form itself. Let me start off by giving you guys some definitions, and let's start with EVEMS, which stands for Electric Vehicle Energy Management System. This is defined as a means used to control electric vehicle supply equipment loads through the process of connecting, disconnecting, increasing, or reducing electric power to the load, and consisting of any of the following items: a monitor, communication equipment, a controller, a timer, or other such applicable devices. The other definition I want to mention is EVSE, which is Electric Vehicle Supply Equipment, previously known as EVCE, but now retitled EVSE, and that is a complete assembly consisting of cables, connectors, devices, apparatus, and fittings installed for the purpose of power transfer and information exchange between the circuit and the electric vehicle. Another definition that we should look at is found inside the Safety Standards Act, and that's regarding the variance itself. And that is a document without precedential value issued for an individual circumstance on a single occasion by a safety officer or a safety manager, allowing for A, a deviation from the application of a regulation under this act, or B, a use other than the standard use of a regulated product if the proposed use is not specifically prohibited under this act. And I think for many of you guys that are in the audience today, one of the big questions that you may have is, do I actually need a variance for what I'm planning on doing? And is a variance required if only an electric vehicle car charger is being installed? And the answer is no. A variance is only required if an energy management system, or EVEMS, is installed at the service or feeder portion of the distribution. Okay, so next, why don't we take a look at the information bulletin itself and some of the prime pieces of information that we want to take from it. And the whole purpose of this information bulletin is to bridge the gap, because in the 2015 BC Electrical Code, Section 86 only recognizes load management on a branch circuit level. It does not include load management on services, feeder conductors, or distribution. In addition, the 2015 BC Electrical Code in Section 8 does not permit the installation of any sort of EVMS systems at this time. In the 24th edition of the 2018 Canadian Electrical Code, EVMS shall be recognized, and they go on to define it as the control of electric vehicle supply equipment loads is the process of connecting, disconnecting, increasing or reducing electric power to electric vehicle supply equipment and connected electric vehicle. And at this time, in order to bridge the gap, Technical Safety BC will consider applications for a variance of Section 8 and Section 86 of the BC Electrical Code 2015 for installation of an EVMS to bridge the gap until 2018 adoption. As far as 2018 adoption goes, it's presently under regulatory review for adoption, and until such time, a variance application process will be needed to recognize any new changes from the 2015 BC Electrical Code. What we should also keep in mind is if you are in a jurisdiction outside of Technical Safety BC, you should definitely inquire within your jurisdiction to be consulted in regards to any installations of EVMS systems. Okay, so let's take a look at the variance process. Okay, some of the general requirements that we're going to come across are identify the rules to be varied under the BC Electrical Code. We're going to want to provide a rationale to support the variance request. We're going to need a clear description of design and operation of your installation. And we're going to want to see a demonstration that the EVMS will not cause the loading of any distribution equipment, feeders, or services to exceed the requirements of BC Electrical Code Rules 8-104, 356, which have to do with maximum circuit loading. Some of the additional general requirements we're going to want to look at is if an administrator is required, we're going to want to see an inclusion of how the loads will be managed and how changes to the connected load, such as any additions, alterations, or removal, are documented. And we need you to clearly indicate when an administrator is required to operate the EVMS. Indicate the administrator plan as part of the terms and conditions. We'll look at that a little more closely when we go through the variance process itself. If the EVMS system requires an administrator to manage, monitor, and control the loads, we're going to need to see an operating permit regardless of occupancy type. We're going to need to see a management plan documenting how the EVMS will be controlling the connected loads, including how the addition or removal of the loads will be managed. And we should also point out that at no time should the load imposed by the electrical equipment exceed feeder or service ratings as determined by applicable BC Electrical Code rules. So if we're going to be needing the variance and we're going to be inquiring about an installation permit, we're going to need to ensure that the permit scope includes all EVSE and EVMS plans and specifications, including load calculations in accordance with the BC Electrical Code, and those must be included with all permit applications. All loads being managed by the EVMS need to be identified and included in your load calculation. The connected load shall be determined by the nameplate marking on the equipment. Any EVSE system with variable load setting shall have the maximum setting permanently marked on the equipment. I can bring up, I believe a Tesla charger has multiple settings, so you will need to, for an example like that, you will need to ensure that that maximum setting has been labeled. In addition to that, you'll need a copy of the accepted variance and any associated documentation, plans and specifications, and any manufacturer's instructions must be provided to the equipment owner prior to allowing the equipment to be placed into operation and prior to final inspection. It's also important to make sure that we're compliant with the Safety Standards Act, and this needs to be verified in writing by an FSR for all the EVSE and EVMS systems prior to final inspection and before allowing the equipment to be operated by the owner. The variance and any associated documentation provided to the equipment owner prior to the equipment being placed into operation and final inspection. If we're going to require an operating permit, and if the facility has an existing operating permit, we're going to need to provide all EVSE and EVS equipment that may be installed under an operating permit in accordance with Directive Electrical Operating Permit Requirements DEC 07 0801 7 Revision 1. All EVSE and EVMS plans and specifications, including load calculations in accordance with the BC Electrical Code, must be identified in the operating permit log. A copy of the variance must be recorded in the electrical operating permit log, and all alterations and modifications to the EVSE or EVMS equipment, including changes to operation of the equipment, must be recorded in the electrical operating permit log. If the installation is going to occur prior to the issuance of an operating permit, we're going to want to make sure a copy of the variance is included as part of the electrical operating permit application. All EVSE and EVMS plans and specifications, including load calculations in accordance with the BC Electrical Code, must be identified in the electrical operating permit log. A copy of the variance must be recorded in the electrical operating permit log, and all alterations and modifications to the EVSE or EVMS equipment, including changes to operation of the equipment, must be recorded in the electrical operating permit log. If you're looking for more information on operating permits, please visit our website at Technical Safety BC, or as we are now into 2019, you can take a look at regions in your area, and you can look for upcoming tech talks regarding electrical operating permits and the FSR. One other point that I would like to make to you guys is the local utility is not regulated by BC Electrical Code, and as such, conditions for a variance require that the utility be consulted and notified of all EVMS installations where the service may be overloaded upon the failure or removal of the EVEMS. All right, the next section that we're going to take a look at now is we're going to do a little walkthrough of the online form application. Okay, so here we are, we're having a look at the online form. Of course, if you don't currently have an account with Technical Safety BC, please go to the website and you can create an account, and that will take you to this dashboard. So the first thing we're going to want to do is we're going to take a look, and we're going to notice that there's a spot that says apply for permits. We're going to want to click that. Then if you come down, you'll notice that at the very bottom there, it does have a request for an EVMS variance. We're going to want to click that. Then we're going to want to click the only box that's available at this time for electrical technology. We're going to give that a click, and then you're going to see that it's going to bring you down to electrical vehicle energy management systems. We're going to want to click back. And at this early stage, you can see some of the items that have red stars on them. Those are all going to be mandatory field, as you can see by the comment in the bottom left section. So do be aware of that as you're going through. We'll press continue. And it's going to give us our applicant information. One thing I would like to point out that you do not, in fact, need to be an electrical contractor to apply for a variance on the EVMS system. So we're going to just have our applicant's going to be Joe Smith, title, Mr., phone number. Fill out a phone number, email, which is another required field. And you'll notice underneath here, qualification, if applicable. You'll notice that none of these have red stars on them. So if you aren't actually a contractor, like I said, you are going to be able to apply for the variance. But if you are a contractor, go ahead and fill those out. In our case, We're not going to be a contractor, so we're going to leave those boxes empty. All right, and then we will have an asset owner, equipment owner boxes to fill in. I'll let those guys get filled in. Those are the addresses. Looks like this fellow's living in Coquitlam, British Columbia, Canada. Looks good. Providing a phone number. And an email. We'll just use our education email in this case. And we'll click continue. Here's some permit information. Of course, it's quite possible to apply for the variance prior to the issuance of any permits. So you'll notice that none of these boxes are filled out. But if you do have a permit already, obviously fill that in. But in our case, we're going to leave those blank, as Mr. Joe Smith is just in the early stage of getting his EVMS system installed. Okay, this is the site address. This is where the equipment is actually going to be installed. And the postal code is going to be a required field. And if it suits you, you could use coordinates to locate the site, but in our case, we just manually typed in the address. If there's anything interesting on the site that you wanted to mention, where the entrance is or where the system is actually going to be installed, you can go ahead and fill that out right there to help with the location. If the building has a name, we're going to fill that out. In this case, it's Buildings Electric City, and the site contact name is Joe Smith, and the phone number. Okay, so and then we're going to get to the electric vehicle supply equipment has approved for the intended use, and we're going to put yes there. Of course, the charger should be approved for its use. We're going to have a certification. In this case, I believe we're going to use CSA. The manufacturer that we're using, we just randomly picked some manufacturers. So today we just happen to have picked a Bosch model. And the model number is so we're going to want to fill that out. Notice that the manufacturer, certification, and model number all have the red stars indicating mandatory field. We're going to want to have a voltage. I believe the Bosch comes with a 240 volt rating. Phase is going to be single. And the actual load that that charger is going to be drawing is going to be 40 amps. In our case here, for our example, we're just going to have one charger, so the quantity shall be 1. In the case that in some instances, some units are going to have a fail-safe value to them, we're going to include a fail-safe here, not necessarily matching manufacturer specs, but just to show you guys that when we present you the little demand calculation later, how you're going to want to factor in fail-safe. So in this case, we're going to give a fail-safe value of 8 amps. Again, not all systems have a fail-safe value, but in the event it does, I just wanted to show you how that operates. The next section we're going to look at is the electric vehicle energy management system itself. Has it been approved for use? And obviously, since we're filling out a variance form at this time, we're going to have to say no. All right, it can still definitely have a certification. And in this case, we're going to use CSA again. And for this presentation, we've just chosen to use a DCC manufactured by DCC Technologies, manufactured by Thermalec. And we're going to go with a model number of DCC 10. Its voltage rating shall be 240 volts. Amps on this guy is going to be 40. And we're just using one. One charger, one EVMS system. Load under control management, amps per unit. We already discussed that the Bosch is drawing 40 amps, so we're going to put 40 there. Since there's only one EVSE, the total load under control is going to be 40 amps. But if in the event that we were using, say, 2 or 3, 2 total load would become 80, 3 would be, of course, 120, but again, I point out we're just using 1, so the total load under control is going to be 40 amps. Now, the next section is going to be the type of control management. In this case, we're going to use monitor. It's going to be monitoring the load, okay? And the next box here is the control management supplied by the manufacturer of the EVSE, a third party, or none of the above? Of course, we're using a Bosch charger, EVSE, and we're using a DCC-10 EVEMS. So we're going to say that the control management is supplied by a third party. The next section is the EVMS capable of managing and controlling loads affecting the following areas? In this case, we're going to say that we're going to be controlling the service feeder, so we're going to put a yes there. And since this is a system that ultimately is going into a single detached home, we're going to say no to feeders, and we're going to say no to branch circuits. Is the EVMS capable of managing and controlling power production equipment bidirectional transfer? As a new technology, as we're moving forward, we're going to find that some of your electric vehicles are going to be capable of not only being charged, but in some instances, providing a secondary power source. If you think to yourself in the event of a power failure or something like that, some electric vehicles will be capable of providing power to your home to cover if you don't have any power in your home at that time. So that is what that question is asking. In this case, we're going to say no, though. Our system will not be capable of that. Does the EVMS require an administrator as defined in the information bulletin? In this case, because the DCC-10 that we used is a self-regulating item, in other words, there's nobody monitoring or controlling it outside of that, we're going to say that no, this system does not require an administrator. All right, then we're going to take a look at some of these rules. Is 8-104 circuit loading going to be used? And the answer will be yes. 8-106 use of demand factors, yes. 8-106-10 and 11 Canadian Electrical Code. Notice that this is 2018 code. And of course, if we go back to the beginning, this is the whole point of the variance. So of course, we're going to tick a box yes there. Notice 8-500 here is again regarding 2018 code, and we're going to click yes there. And 86-300 electric vehicle supply equipment branch circuits, we're going to click yes there. We're going to go down and we're going to select our occupancy type. I've already briefly mentioned we are just going to be using an example of a single dwelling in this case, so we're going to use 8-200. No other conditions to apply for any other occupancy type, so we can leave that blank. Notice there's no red asterisk there. Now the next section that we're going to look at through the variance is going to be the terms and conditions, and these are things that you're going to want to be very cognizant of as you read through these. And the first box is the asset holder, equipment owner will appoint an administrator or an authorized agent of the administrator to be responsible for operating the electric vehicle energy management system if required by the EVMS. And of course, there's no administrator in this case, so we are aware of that, but we will definitely click that box. In the event of a breakdown or malfunction of the EVMS, EVSC communications, or electric vehicle response, the EVSC will disconnect power to electric vehicle. The EVSC will establish a fail-safe condition if there's a loss of communications between the EVMS and EVSC. If the EV does not respond appropriately, or when it is evident that the automatic restarting or lack of communication is liable to create a hazard, once safe operating conditions are restored, a safe startup of the EVSC will be ensured. We're going to definitely want to make sure that we've looked at that and are able to click that box. The fail-safe process installed in the energy management system will remain in effect for the life of this equipment and will not be altered in any way. We're definitely going to want to be able to click that box, so we will not want to see any alterations done to the equipment. As I mentioned earlier, original documentation, including installation and maintenance instructions, plans and specifications, and any commissioning reports or other documentation associated with this variance, the EVMS and EVSC shall be provided by the installer to the equipment owner. So do ensure that if you're the installer, that you have passed along to your customer all the important documentation associated with this installation. And also, if you are the installer, you're going to want to make sure that you provide clear instructions to the owner, and will include a description of records that must be maintained by the owner. You don't want to be able to click that box. We're going to want to make sure that the safety attributes of the system will be verified and documented in the commissioning report. The report will be provided with the inspection request to energize the system for installation permits, or in the case of an operating permit, the declaration into the logbook. We're going to want to make sure that we're able to click that box as well. Products included under this variance will be maintained in a safe manner, and all maintenance records will be kept by the owner. So we're going to want to make sure that the system is maintained and all records of the maintenance are kept. The EVMS will not prevent the load of any regulated equipment to exceed the rating of any equipment. So we're going to want to make sure that we're not overloading any circuits. And of course, that's going back to Section 8 code. So we're going to want to make sure that we've ensured that the system will fall under those parameters. And a very important box here, not that the other ones aren't, but the EVMS will not adversely affect the operation of any life safety systems, essential electrical systems, and emergency electrical power supply systems as defined or referenced in the BC Electrical Code. So we're going to want to make sure that the EVMS is not going to affect any life safety, and that's obviously a really important detail, so we will definitely want to be able to click that box. Oh, I think I might have skipped a box, so we'll just take a look at that. The EVMS will be continuously operational when charging is occurring. In other words, that EVMS system has to always be online while that EVSE is in operation, and we're going to be able to click that box. An EVMS that has the ability to manage and control an electric vehicle used as an electric production source will not provide power to loads in excess of the output rating of the production source equipment. In other words, if you do happen to have a setup where your car is able to provide additional power to the system, we're going to want to make sure that if we are adding the electric vehicle as a piece of supply equipment, that we're not going to be overloading the system with that. So that's a fairly new technology which may not be applicable to many of you at this time, but you're definitely going to want to make sure you've taken a look at that. The permit holder will be responsible to maintain a management plan that controls the loads on the electrical system, including the demand loads on the system. So we're going to want to make sure that we can click that box. The permit holder will be responsible to maintain a management plan that controls the loads on the electrical system, including demand loads on the system. I feel like I've skipped the box. Did I miss a box? I think I did. The permit holder, equipment owner, administrator, and operators will be provided with the necessary training to operate the system in a safe manner. Confirmation of this training will be documented and made available to the authority having jurisdiction upon request. All right, there we are. That's the guy I missed. And the next box, the operating permit holder will document in the logbook the addition, alteration, or removal of the equipment. All right, that's going to be very important. And the last box there, provide any evidence that the alternative will meet the objectives identified. In our case, we have some documentation that we're going to include in there, so you could write in see attached documentation. All right, as we continue on, a copy of the certification record for the EVSE from the certification body or a copy of the SPE 1000 inspection report is attached to this application. We're definitely going to want to be able to click that box. Plans and specifications of the equipment and electrical systems, including load calculations and managed loads, referring to Rule 2-014 and 8-106. We're going to want to tick that box. For third-party EVMS, documentation of the suitability of the system with the EVSE. So in other words, if the EVMS and the EVSE are different manufacturers, we're going to want to see some kind of proof that they will work together satisfactorily. Okay, in our case, we do have some documentation that we're going to drag and drop into our variance application form. And the documents that we have are, we do have a load calculation that we've made. Maybe we could start with that and we could just take a look at it even. So as I said before, we just did a simple variance application on a single detached home. Here's an example of a load calculation for that home. So this is the calculation prior to EVMS or EVSE added in. If we can just kind of scroll down. Okay, I've just included some of the rules on this side. Keep going. Keep going. Oh, okay. And as you can see on our home prior to an EVSE being installed, we had a total wattage of 41,850 watts on a 240 system. That calculated out to 174.3 amps. If we refer to table 39, of our code book, we discovered that that was a 200 amp service. So that was the service that we're starting with. Then this customer, Joe Smith, decided that he wanted to add in an electric vehicle into his life, and now he needs to decide on what to do. So now he's purchased his vehicle and he has his charger, and now we take a look at the load calculation with just a charger. And you can see here, here's your EVSE added in here, 9,600 watts. Total with the EVSE brings us now to 51,450 watts. And unfortunately, now that turns into a total amperage of 214.3, which is obviously exceeding our 200 amp service. And the whole point of the EVMS, or one of them anyhow, is to avoid situations like this. So now Joe decided that he wanted to include an EVMS with his EVSE. And here's what the load calculation is going to look with an EVMS system added in. Now, as I said earlier before, I'm just using some pieces of equipment as examples, not necessarily matching. I wanted to include the fail-safe value in there so you guys could see what to do if you have a fail-safe value that you have to calculate in. I do understand that the DCC, I do believe, actually technically has a 0 amps for fail-safe, but I've just included this in here just so I can show you how to go about doing it. You can see we have the EVSE at 9,600 watts. Now we've included our EVMS, but because I did say that the fail-safe was going to be 8 amps, 8 amps at 240 volts is going to be 1920 watts. So we won't be able to completely cancel out the EVSE with the EVMS. So what we're going to be able to do is deduct everything but the fail-safe value. So in this case, you can see 9,600 minus that 1920, which gives us a difference of 7680. So we're going to be able to take 7,680 watts off our total now, which is going to leave us with 43,770 watts in this case. We do our little calculation, divide that by 240, and it turns into 182.3 amps, and we refer to table 39 again, and as you can see, we can still maintain that 200 amp service. Okay, so there was just an example of the basic load calculation that we're going to need you to fill out and submit in, so we might as well drag and drop that into our box now. Okay, it looks like it's included in there. We also have all the specs and documentation for the Bosch charger, so we're going to want to include that in there as well now. Okay, also already I can notice here that the DCC documentation has also been added in there. Of course, in there is any certification values or bodies that have approved the equipment will be included in there as well. There's the installation manual for the DCC-10. And there's the Bosch information there. I don't have a whole lot to add on to those two guys for information. All right. Let's carry on down. Now we're just going to do a declaration. So before I fill out the name, I will point out that underneath there, it does say, I am the person in charge of the work described in this request for variance and authorized to make this request on behalf of my employer. Or you're not the person in charge of the work, but authorized to submit this declaration on behalf of the applicant or employer. So we're going to fill out our name, and it's Joe Smith. So he's not in charge of the work because he was just a mister. He wasn't a contractor. He's just applying for this variance. So he's not in charge of the work, but authorized to submit the declaration. Underneath, you're going to want to make sure that you acknowledge that you've read the information on the information bulletin on the EVMS system. And you're going to want to fill out, if the variance is granted by this application, you're going to agree to all the terms and conditions set forth. I have an example of an accepted letter that we can take a look at in a few minutes. You're also going to declare that the utility has been made aware. As I mentioned earlier, Technical Safety BC does not regulate the utilities, so you are going to want to independently make sure that you've contacted them to make sure that they are aware that you are trying to install a system like this. You're also going to want to ensure that the asset holder and installer are promptly given a copy of this application and the variance. The owner of the EVSE or EVMS equipment will be required as a condition of the variance to have an electrical operating permit in force at all times if the installation is one that would require an EVEMS administrator. The applicant must advise the owner of the equipment of this requirement immediately. So in other words, if this system is going to require an administrator, you're going to need to make sure that the owner of the equipment is fully aware that they will need an operating permit down the road after the installation. You certify that the information that you've provided is accurate and true. I'm sure you guys are all honest, so I'm sure that's going to be correct. And last but not least, it's important to keep a look and notice that when you submit this form, it is considered a signed document. When we're all done, we can go ahead and we can preview. And you have one last opportunity to go over all the information that you've submitted and make sure that it all seems correct to you. And as I take a look at this, I think that we seem pretty happy with what we see. We'll scroll through. To the bottom. And we are going to now submit the form. And we have the form submitted. There's a receipt for submittal. You can choose to print or save it as a PDF. I'd just like to thank Karen in the background here who did all the typing for me. I would have had a lot of trouble trying to do both at the same time, so thank you very much. If I could now have control of my screen again. All right, we've now taken a look at the application walkthrough of the variance online. There we go. One last detail that I'll just mention, if you do not provide us with a complete application, the variance application will not be accepted. So do make sure that you've taken the time to fill out the form completely. Some of you may be wondering how many permits we're going to need. Some common examples. All right, this is a new or existing building, including single detached homes with an EVMS installation plan. So the first thing you're going to want to do is apply for the variance. Once the variance has been accepted and you can move forward, you can then apply for your installation permit. Then the question becomes, does your EVMS system have an administrator requirement to it? How about we say no, and we'll see what we need to do next. So no administrator, we can go ahead, we can do the installation after the variance application with our permit, and then we will just finish our installation, no operating permit required. But what if we do have an administrator? Let's take a look. We'll apply for our variance, we'll get our installation permit, we decide that yes, this system does in fact need an administrator, so we will have to go ahead and apply for an operating permit. All right, so with an administrator and an installation, you will need an installation permit and an operating permit. And once you complete the installation and it's all successful, away you go. If you happen to be in a building that already has a valid operating permit in place, you're going to apply for the variance, and then you can go ahead and complete the installation in accordance with your operating permit requirements. If you need to freshen up on those, of course, I've put up here, there is a directive on that, and that's DE3 07 0801 7 revision 1. And you can then complete your installation. Now that we've done all that, let's take a look at a variance acceptance letter. So as you can see, this person here has come back, in this case, a fictional person, Dave Jackson. You can see the information, and it says, as per submitted, variance request application decision, right underneath here. Oh, I think I can get you a better screenshot for that. There we go. Let's take a look in the decision, and it says your proposed variance has been accepted on the terms and conditions requested in your application. So all those current terms and conditions that we ran through, those are very important. If we take a look at the rest here, it's just reminding you of all those terms and conditions, those boxes that you were ticking. It lists them there. I'm not going to run through them again one more time. 12, and of course there was a total of 14 there. All right, it gives you some additional information. It gives you the safety officer who reviewed your application and a contact for that person if you such require that. That's going to conclude my portion of the presentation. And at this time, I'm going to invite our Senior Safety Officer, Brad Sullivan, to take over the balance of this to answer any of the questions that you may have. Thank you very much.
So the computer's off now. Okay. Thank you very much, Rob. I think we're live. My microphone is working fine. Thank you, Karen. Great job, Rob. Really well done. And I've had a few questions. I've tried to respond to a few of your questions over the chat line while Rob was doing his work. And there was a couple that we still needed to talk about. One I want to talk about is the question came in from Michael, and that was with respect to addressing townhomes and condos where feeders can't easily be upgraded. This is posed to be a significant issue out in the field, talking to some of the contractors that have tried to do this. And it brings back a memory of whenever we were installing heat pumps and hot tubs as add-ons after row housing and condos, et cetera, whenever they became popular. And overloading of the service became something that had occurred if not the necessary precautions or service upgrades were done. However, with the electric vehicle energy management system, there still may be opportunities for for you to install supply equipment without having to increase the service. So if you have a couple of opportunities here, I'll talk about. Number one is that there is an opportunity to contact the utility, Fortis, Hydro, et cetera, and ask whether or not a second supply service could be brought in and deem it to be a complex structure. And that second supply would go into, say, the parkade, of an apartment building or a townhouse complex into the parking area, and it would serve the electric vehicle charging systems. That's one opportunity you have, and therefore the original design of the housing and stuff would be untouched. The only thing you may have to do is you may have to cross-hatch the life safety systems if it's in a closed parkade. You may need to cross-hatch that with the fire alarm or pressurization of ventilation that needs to be activated whenever charging was occurred. There is some, it's a little bit of work to do there. When you want to tie into a second place where you want to tie in right into the actual townhouse and onto the individual meters, that's where an energy management system requires the cooperation of the entire condominium and the strata probably, and that there needs to be a plan put in place. The new energy management systems, for example, on a single branch circuit, there are some out there that you can put 4, 5, 6 charging systems on, and if they're all rated at 32 amps, they all operate on a single 40 amp circuit, but they all have individual IP addresses. And the software, the energy management system that they operate under, controls all of that, controls the power to each of those units depending on the number of vehicles that are installed, depends on the priorities that you set, depends upon the asks of the owners, and it's all controlled, all based upon the fact that you never exceed a single 32 amp or 40 amp load. Sometimes if everybody's plugged in, they may drop it back down to trickle charging, but then again, over a period of 10 or 12 hours overnight, everyone should have a pretty close to full battery by the next morning when everybody needs to go to work. So you have to ask the question of the owners as to what is it that you're looking for. If you're looking for a level 3 charger and you want to go a full-on DC charge and you want to be charged up in an hour, you're definitely going to be looking at bringing in the utility to drop in another service so that they can work independent of the regular house loads. So I hope that answers a little bit from Michael on your question. Now, another question I had was, here it is here, do we need to test with full loads on all of the systems, or is a theory acceptable to demonstrating that it is working, the energy management system is working properly? I think there's a couple places to start, right at the design stage. Let's take a look at whether or not the supply equipment is cooperating with the energy management equipment. We need to take a look at where is that energy management equipment residing? Is it residing in the cloud? Is it residing on someone's phone? Who has control? And where are the controls going to be kept and maintained? As you start to work through that theory and through the processes of that, then you can start to look at whether or not the theory is going to work in concepts. As you start to install the equipment, I think that it would be important to at least test each one of the chargers to make sure that they are operating properly. Whether or not you have a vehicle that does that for you. There are now available trailers out there that people are using as trailers with full sets of batteries on them, and they're going around offering roadside assistance for electric vehicles for a quick charge. So you may be able to use those as a load bank to do some of your testing. And I think where we land on all of this is that obviously I think it would be unreasonable if you had an apartment or a high-rise that had 50 charging stations and you were expected to put 50 cars plugged in and then take pictures of all the 50 cars and license plates. I think that's a little overkill. And I'm being a little tongue-in-cheek on that. But I think if you can demonstrate some kind of a theory that works and that you've tested each one of the systems and you've come up with some kind of a hybrid that to the test of a reasonable person would say that it's working correctly, then I think you're good to go. Let me take a look at what else we have here for questions. One moment, please. So one other question that came up is that how do we know whether the electric vehicle supply equipment is compatible with the electric vehicle energy management system, and what would that look like? What we've looked at that is that in many cases, the electrical vehicle supply equipment will talk about in their installation instructions what energy management systems that they've been tested to, and that they will offer either their own energy management system, like the Tesla system does, or they may recommend a third party that will work for them. On the other hand, is that an energy management system, electric vehicle energy management system, will also say is that their system is compatible with the various different chargers. So what you're looking for is that written documentation, installation instructions, and coordination between the two parties. Where you run into some may run into some issues is with respect to prototypes or one-ofs, etc. Then you may run into some issues with that. So we're wanting to know that both the energy management system and the supply equipment have talked to each other before they get to the job site, and that they know that each other are going to work hand in hand, and that we're going to have a nice, safe system at the end of it all. Do we have any other questions out there? Looks like we have nothing on the chat line. Is there a few more? Okay. Oh, I see. One moment, please. Let me just catch up. So I have another one here. It says, if the installation is in Vancouver, do we apply for a variance with the city or with Technical Safety BC? Michael, great question. If the local municipality has inspection services such as Vancouver, Burnaby, Maple Ridge, Vancouver, North Vancouver, District of North Vancouver, West Vancouver, Surrey, and Victoria, then you will apply to that municipality for your variance. If you are installing the equipment in the jurisdiction of Technical Safety BC, where we provide inspection services, then you would apply to the Technical Safety BC in a manner that Rob has demonstrated here. Next question we have is that when would an EVEMS be moved to a feeder or service? This is sort of new to me. Okay, Matt. Well, listen, in the 2015 code, the 2015 code recognizes electric vehicle energy management systems at a branch circuit level. Section 86 says that you can have multiple charge equipment on the same branch circuit or shared branch circuit. This was an introduction in 2015 that recognized that there is some very unique aspects to this supply equipment, and it has the ability to share. By each of them having unique IP addresses, the software and the controls now can manage through the IP address. What the 2018 code has done is said that this aspect of things has been successful, so successful that we're prepared to move this management system into feeders and services and allow you to share that. What will that look like in the field? Well, it'll look like a current transformer, for example, inside of a panel strapped around your feeder, and it will be managing, or shouldn't be managing, it will be monitoring the current at that feeder. By knowing that current in that feeder, it will then allow the power to be released through the supply equipment at the chargers to charge the vehicles. So there's a handshake, a monitor and handshake involved with the supply equipment. Likewise with the service is just one level up in the distribution, and it too will be monitoring the amount of ampacity through current transformers. Where we run into some trickiness here was with the energy management systems is that the energy management system needs to know what the size of the overcurrent and the protection is, so that it doesn't overload or provide too much power or allow too much power to be synced or taken away into the charge systems and put the distribution system in jeopardy. That's where the energy management system has to be smart in its setup and in its programming. So next question is that are there any special qualifications required of an administrator? An administrator must be able to demonstrate to the regular authority having jurisdiction the ability to manage safely the energy management system. This is going to require knowledge of how to enter things in and out of the logbook. It's going to have knowledge of what each of the energy management systems have the capability and capacity of. They probably will need to know a little bit about how the structure of it of the distribution is, what the components capabilities are of it, and understand a little bit about that. I think that working with the energy management companies and the supply equipment companies is that the administrator can become a manufacturer's technical representative in a slang kind of way, and that would be the obligations that an administrator would need to be able to demonstrate. At one point, we talked about here as putting a definition in for an administrator. The difficulty with setting the administrator as a definition is that this industry is changing so fast and so rapidly, and there are so many combinations and permutations available. We found it very difficult to be prescriptive in this mode, and we wanted to provide a little dynamic ability for the administrator so that they could be able to go with the flow, so to speak, with the new technology as it comes upon us. Next question. Follow-up question on townhomes with individual garage. The complex has 10 to 20 units. Would we have to do a demand load for the complex or the unit that the unit is being installed in? I believe that you would have to do a demand calculation, and I think that you would be able to probably get get the demand load, I believe is the correct term, get the demand load for the complete complex. The reason being is that you need to make sure that the addition of the energy management or that electric vehicle supply equipment is not going to put the size of the service in jeopardy. And if you can demonstrate that, then you may be fine. But if you're putting a single charger supply equipment in with a single charger, the energy management system may be able to operate right inside the household. So you may be able to put that energy management system on your dryer and range, depending on the size of things. So you may be able to share loads within the house or within that unit and not overload the feeder or the service. And I would look at that very carefully. One of the things that we found out is we have to be careful of is that in the strata situation, say you have a 4-unit townhouse, if you add extra load to the service without consultation with the other members of that strata, when those other members require additional loads to the energy management system, now you have to defend the reason why you've taken that chunk of the load that was available, and now that's not available any longer. So it's very important to communicate with the strata when you are monitoring or doing assessments based upon the size of the service or the feeders to those particular units. Is a variance needed for all EVSEs? The answer is no. If the electric vehicle supply equipment and the energy management systems can fit within the requirements of Section 86 at a branch circuit level, then no variance is required. Next question is from John. In a condo building, in each unit that has a DCC 9 installed, I'm not familiar with the 9, limiting each unit's load to 200 amps or less, how is the total building load limited to 1600 amps, for example? Okay, a little bit complicated for me. I'd have to find out some more information on that. John, would you be able to send me some more information, or maybe we could talk about that a little bit offline? That sounds like that's more than a 30-second answer. Yes, sure, that's fine. Thank you very much, Karen. John, Karen's going to send you a note. Thank you. Hi, Rob and everyone. This session has been recorded and the recording will be made available. Thank you very much. Oh, okay. So is the open charge point protocol recognized or accepted already? To the best of my knowledge, no. It has not been accepted. If it is going to be accepted, it will be accepted on a one-of basis, variance by variance by variance. The Canadian Standards Association has recognized that the 2018 code has asked for a requirement that does not exist. They were expecting that the electric vehicle energy management systems would be approved and that they would bear evidence of approval and would have all of the conditions that we have set in this bulletin. A few months back, a presentation was made with this bulletin to the national board, where they discussed some of the ideas that we've identified as needing to be improved upon. And the outcome of that is that the Canadian Standards Association is developing a electric vehicle energy management system software certification program, whereby certification will be available for energy management systems. Once we have that, then the answer of open charge point protocol would then be able to apply to the Canadian Standards Association or other certification bodies and get approval. At this point in time is that we are looking for each of these individual management systems to demonstrate on a one by one basis through a variance process that they meet the requirements. Sorry, there's some, I love this, is that we've started a chat line, and it looks like we're scrumming away here. Everyone seems to be talking to each other, and this is great. I can stand here and just keep reading. I find it quite enjoyable. Thank you everyone for stepping up and providing assistance. So the next one is, what standards must the EVSE and EVEMS equipment be approved to? Well, the electric vehicle supply equipment is presently being approved to 3 different standards that we have identified. There is one standard for electric vehicle charging equipment. Other manufacturers have gotten approved to industrial control equipment, and some other ones have gotten approved to rectifying equipment. Because the electric vehicle charge equipment standard was late to the game, certification bodies provided certification to the other standards who have been around for a while, such as industrial control and rectifying, in advance of this standard. We at the Technical Safety BC and our representative at the national boards have identified this as a gap, and we've asked the certification and inspection bodies to reassess and look at these variations, and that to report back to us with a plan to move forward so that everyone will be certified and approved to the same standards. In the meantime, we're continuing to monitor all of this. Some of the information that's being asked of you during this variance process is for just that, is so that we can monitor what kinds of equipment is out there, and that we can also monitor whether or not that equipment is working as intended. And that if there are any issues with it, we can then report back to the national board as they work forward and work on towards getting a national, unilateral, and uniform standards and to be certified to. As for the electric vehicle energy management system, there is no certification program for it, as I explained, and that's one of the main driving points of this variance process and information bulletin. The expectation as the standard gets developed is that at the end of the day, all of the energy management systems will be approved. You'll be able to buy them off the shelf, buy them through the Apple Store or Google Play, etc., and you'll be able to just load them and carry on. I hope that helps. I'm closed up. Oh, there was a question here. We have a question from a couple of people in our room here. Would we accept a peak demand, 12-month peak demand reading from BC Hydro for the purposes of doing a load calculation for EVEMS? The answer is yes. And okay, so one of the questions that's come up with respect to the townhouses and townhouses with a shared main service versus townhouses that are individually supplied. So townhomes individually supplied, the distribution there is somewhat similar to that of a single family dwelling. And I would look at the introduction of an energy management system or an electric vehicle supply equipment in the same manner as I would look at it through a single family dwelling. So depending on the number of chargers, depending on the size of the chargers, the type of chargers, etc., you may need to switch one load. You may need to switch more than one load. If you need to switch more than one load, that's not directly related to the branch circuit that the supply equipment is going to, then you will need a variance and you will need a management system. In many cases, that management system does not necessarily need to be a complex system sitting on your phone. However, you know, as a techie, I would love to have one of those. But you could do it through the old-fashioned load miser systems and run some hard flip-flops, hard contactors at on-offs. That's perfectly acceptable. In other cases, you may introduce a series of some timers and control timers where set up through some coils and contactors that you could build under permit to build a timer system that your supply equipment or your charging would only occur between 12 and 4 in the morning. Unless there's an override system of some sort, and then you could set up some kind of a manual override. But the sky is the limit, to use your imagination. At the end of the day is that, do you have a safe system, and is the service or the feeder or the branch circuit going to overload? Shared services with the main service is the other one. This gets more complicated. As soon as you start to affect common or shared distribution equipment, everyone who shares that distribution equipment needs to be in the conversation. And that way, everybody has the opportunity to get involved, and everybody has the opportunity to also understand what the consequences of adding load to a shared system. Once you start into a shared main service, your opportunities become that you're going to need to use an energy management system more than likely, unless your service is so oversized that there was room for it. One of the things to always be careful of, and this is what we talked about, the fail-safe mode, is that we want to make sure that in the fail-safe mode is that the bandwidth, I call it, the bandwidth that has been designed or set aside, the power has been set aside for a fire pump, it's been set aside for stairwell pressurization, has been set aside for fire alarm, has been set aside for emergency lighting, set aside for an elevator, etc. All of that power that's dedicated for Section 46, Section 32 requirements, that is intended to sit dormant until called upon, should never be touched. Or if it is being touched, it has to have the ability through the management system to fail safe. In other words, it's got to be so quick and reactive that if the fire pump calls, there can't be any risk of that fire pump not operating effectively, efficiently, and quickly, and that we're not going to take out part of the distribution upstream. In the Section 32 requirements of fire pumps, if you take a close look at that, we're integrating right back to the service. So if a fire pump doesn't have the power to fire and that service gets overloaded, there's a very good likelihood that the service itself is not going to trip. There's a very good likelihood that the transformer at the hydro utility is going to blow a fuse. If we lose that and we lose the service, our entire life safety systems are in jeopardy. So when you're designing and when you're building and when you're constructing, please always keep in mind is that there is a bandwidth in your design of emergency and life safety that you really want to stay away from. And that is one of the key precautions that we've set forth here in this fail-safe comments and fail-safe statements that we put into this bulletin. I hope that helps. And I'm going to take a look here again, see how much more we have. How am I doing, Karen? Anything else am I missing?
Just one question from Steve that came in. Oh, it's on just that.
Oh, okay, I see that. Message from Steve. The DCC-9 for condos is designed to not overload an individual unit feeder, such as a feeder from a meter stack. If a meter stack has 6 100 amp main breakers, it will be fed at a lower amperage than 600 amps. Okay, I don't know the concept, or I don't know the concept of the DCC-9, Steve. This is getting a little bit deep for this venue. Would you be so kind as to send me some details on this, please? Perhaps the location of where you're planning on installing it, and then we can get the local safety officer involved in this. It sounds to me that that's something site-specific and a little bit outside or a little bit more detail than what we want to talk about at this information bulletin, if you don't mind. Looks like we are running close. Finished? Okay. Thank you, everyone. I believe we had a huge turnout here. This is the second one. We're going to take it back and take a look. If there is interest, we'll maybe throw a third one up, but we're not, at this point, not committing to that. Hope everyone has a safe day. Stay warm. And thank you very much to Karen. Thank you very much to Rob. Thank you, everyone out there in the industry for supporting Technical Safety BC. And we will talk with you again. Thanks.